Welcome to Study Loop.
In this problem, we're asked to calculate molarity. Recall that the equation for molarity is given by moles of solute divided by liters of solution. In part A, we're given mass of the solute, mass of magnesium nitrate, and we're given the volume of solution, but the volume is given in milliliters. So the first thing we need to do is change our volume from milliliters to liters. We do that by dividing by 1,000. So this is going to give us 0.2500 liters of solution. Again, I divided by 1,000. And then to change mass to moles, we're going to need the molar mass of magnesium nitrate. So we're going to start with the given mass, 0.540 grams. And we're going to divide that by the molar mass. If we use our periodic table, we find that to be 148.3 grams for every 1 mole of magnesium nitrate. You see that the grams units cancel, and we get moles of magnesium nitrate, 0.00364. And again, this is MgNO3 2. Now that we have moles and liters, we can set up our molarity equation. So we write 0.00364 moles divided by 0.250 liters. And what that will give us is 0.0146 moles over liters. And we can write moles over liters as molar. So our units are molar. We can also write this in scientific notation as 1.46 times 10 to the negative 2 molar. And that's the concentration of magnesium nitrate. In part B, again, we're given mass and we're given volume. We're going to do just as we did before. We're going to change this volume to liters. So this is 0.125 liters. And for the molar mass, we need to make sure that we find the molar mass of that entire formula. So when we do that, we're going to start with 22.4 grams and divide by the molar mass, which is 160.4 grams for every mole. We find that we have 0.140 moles. That's a 0. And this is moles of lithium chlorate. It's technically moles of lithium chlorate hydrate, but it comes out to the same thing because there's 1 lithium perchlorate. Sorry, this lithium perchlorate. The way I got the 1.40 is my calculator said that this fraction was equal to 0.13965. And so I rounded to 3 significant figures. Now when I set up my molarity equation, I will again write moles of solute over liters of solution to find that this is equal to 1.12 molar. In the last problem, we're not given, it's a little different. We're given a volume and a molarity, and then we say we're taking that solution and we're diluting it. And so a lot of people are inclined to jump into an equation, but it helps to understand why the equation works. So let's say I have a beaker, containing my 25 milliliters of solution. And this solution contains a concentration of 3.50. So let's represent the solute with these dots. So I've put in 10 dots representing the solute nitric acid. And what we're going to do is we're going to dilute this by adding just water. We're not adding more solute, we're just adding water to increase the volume. So when we do that, we're adding all of this water, but we're keeping the number of moles of solute, the amount of nitric acid, the same. So notice what I've done to the concentration. I've decreased the concentration by increasing the volume, and the number of moles has not changed. It's the same in both. So what does this do? What I've done is I've increased the concentration. By the way, 250 liters, I should clarify, is the same thing as 250 milliliters. Notice that I've increased the concentration by 10. I've increased the volume by a factor of 10, which means my concentration is going to decrease by a factor of 10. So if my concentration was initially 3.50 molar, when I decrease it by a factor of 10, it ends up as 0.350 molar. Now I know that a lot of students like to have a formula to kind of back this up. That formula is given by C1V1 is equal to C2V2. You might also see those C's as M's. They all do the same thing. But essentially, the initial concentration and volume multiplied together is equal to the final concentration and volume. Final concentration and volume multiplied together. And so we were given the initial concentration, the initial volume, and the final volume. And what we were asked to find was the final concentration. So we can write this as C2 is equal to C1 times V1 over V2. And when we plug in these values, we find that our initial concentration is multiplied by 25.0 milliliters over 250 milliliters. Notice that this fraction is equal to 1/10, which is the same thing as what we found with our initial approach.